Trying to build AI for a game is hard enough, but trying to build a game that teaches you how the AI works is no doubt even harder. Over the years here on AI in Games, we've dug into the complexities of many of your favourite titles, how building enemies, allies, adversaries and opponents can be a massive undertaking, with numerous complex systems running in the back end to deliver the experience you've enjoyed for dozens, if not hundreds of hours at a time. But the AI in those games is finished. It's done. When the game ships, the AI is final, and it won't develop any further, bar fixing the odd bug or two, of course. This is what makes Little Learning Machines so interesting. A game not just about training non-player characters using contemporary AI techniques for in-game challenges, but the training process is reliant on players learning the fundamentals of how the underlying technology works. I'm Tommy Thompson, and for this episode of AI in Games, we dig into the making of Little Learning Machines. I sit down to chat with some of the team at developers Transitional Forms about bringing the project to life, discussing some of the weird and wonderful challenges they faced along the way, and how the team itself had to learn more about how machine learning actually works in order to build a game that is accessible to everyone. Released in early access in 2023 and now with a full release in 2024, Little Learning Machines tasks players with solving a variety of increasingly challenging puzzles in a fun and idyllic environment. The challenges can range from collecting items, navigating hazards, watering flowers, or playing with dogs, because who doesn't want to pet the dog in a video game, am I right? But in order to solve these puzzles, the player has to teach non-player characters known as Animos how to solve the tasks presented. You train each NPC in real time using the dedicated training cloud, where players get to design their own sample problems and then configure the Animos to understand how they should solve them. The game itself originates from the studio's previous project, which was actually an interactive film. Agents, released in 2020 and available on Steam, as players work to maintain the ecosystem of a collection of intelligent NPCs. Players can interact with these agents to sow conflict, or to protect them and ensure their survival, and in turn, these characters will react to the player's inputs. As Agents was close to completion, the team had become enthusiastic, not just about understanding more about how the reinforcement learning technologies that powered the NPCs actually worked, but also how they can have much greater control over how the characters behaved. This led to the development of Little Learning Machines, where the team not only wanted to experiment with the idea of training NPCs as a core mechanic, but also take on the challenge of teaching players how the underlying technology works as they play it.
We would come into the studio in the morning and all get around the computer and see what they had learned overnight, and just that process of of us seeing these kind of being excited by new behaviors and different things like that really inspired what we want to do. And I know Dante did a lot of work, especially near the end of the project, that naturally was trying to get the training more in my hands and Pietro's hands and anyone's hands, so that we could actually, as much as we're not engineers or anything, that we could actually influence their observations or at least have some sort of degree of influence over them. And from that, immediately we were like, that is fun. It takes tens of hours at this point, but what if what if that loop could be closed and we could make this loop tight enough that it could be experienced right in front of your eyes? That was always the core idea, even before we knew that there are robots or anything, just in the early diagrams and things.
So one of the missing points early on in this RL space is this idea that there's all this theory behind it. And then we often, as users, interact with reinforcement learning algorithms, in YouTube, or recommendation algorithms, or naturally reinforcement learning based. But what's kind of missing is this little thing that undergrad students do when you ask them to hey, can you run some experiments? Where it's this loop of training something, watching it improve, being oh, how can it get better, and then molding that. And whatever that experience was, it was a little intuition experience, and we wanted to capture that. And at least it was our original thought that was something that I think that we thought that could only really be learned through intuition. through doing it multiple times and like developing a sense for how these things like behave, and it's always like specific to your algorithm, like or to your like AI or creature. It's very close to game design in that it's an iterative process, but then so trying to create a space where people could experience that and develop that skill is something that we thought was just kind of absent.
So yeah, Little Learning Machines is a game all about training AI to solve problems. But I'd be remiss if I didn't point out that there are games that have explored this idea before. Creatures from 1996 and Black and White from 2001 are famous for being games that had NPCs that the players could train and configure over time. But it's not an idea you've seen applied to games all that often. Both the Norns of Creatures and the monsters of Black and White are powered by artificial neural networks, where they are slowly tweaked and modified over time to better suit the goals of the player. But the design of each of these games is rather freeform, allowing you to explore lots of different ideas and manipulate these characters at your own pace. But for Little Learning Machines, it's quite different. They need to be able to solve a puzzle in front of you, and they need to do it quickly. Now, Little Learning Machines uses the same core architecture. The Animos brains operate using neural networks, but they're trained using a contemporary reinforcement learning algorithm. For those unfamiliar with the concept, reinforcement learning is a process whereby an agent learns to solve a problem through repetition and experience. The problem is broken up into states, unique situations within the range of all possible problems, and in each state it can apply an action. After each action, it then receives either a positive or negative signal. These signals, often referred to as rewards, help the agent understand whether it's doing something correctly or incorrectly. The more it experiments and tries different strategies, it begins to learn the most effective actions to take in any given state. In Little Learning Machines, players are exposed to a collection of puzzles and a UI in the cloud that allows you to configure the learning process. And for those of us who know a thing or two about machine learning, it will all look rather familiar. The puzzles players face off against share similar properties with many of the formative examples anyone who has read a textbook on reinforcement learning will have encountered, complete with a discrete grid structure with objects of relevance and goals that are to be satisfied. In each of those textbook examples, the goals are defined and the rewards are identified, given the focus is on teaching you how the underlying algorithm's mathematics work. Little Learning Machines takes this concept and turns it into a puzzle. And this is for me the most interesting aspect of the game, in that players need to be able to train an animal relatively quickly, within 30 seconds or a minute or two. And this creates a big technical challenge of ensuring the underlying AI infrastructure is sufficient and up to the challenge of making this process fun without it becoming too frustrating.
We came up with a metric that is like non-standard for, I mean, maybe I haven't read enough papers, but there's like a metric that we kind of used, which is time to first intelligence, which is really just how long can you ask the player to wait before they see something cool happening, which at the beginning when we started working on this was like 5 minutes, which was a lot. But now, like later on, we were able to get it down to like 20 seconds, which was closer to where players were like, oh, it's doing a thing, before they kind of thought that they were doing something wrong. So that was like one of the metrics. But then on the other hand, when you're like, oh, how can it do anything that you set it to do? Well, that's the other metric, which is maximum intelligence. So the entire point of this game, or like the entire like balancing of the hyperparameters, is to find like a good balance between time to first intelligence, so you want the agent to learn quickly, but then you also balance that against how much can it learn overall. This project was like a Hail Mary from the beginning. It was always like, is this even possible? And it was just like a continuous like step of, oh, that's possible, oh, that's possible, oh, that's like, it was just continuously like trying to do something very weird, very new.
The AI pipeline within Little Learning Machines is certainly one that most developers won't put into their games, given most games that adopt machine learning for in-game behavior will have the models pre-trained. They're trained during development of the game, or in some cases they're developed outside of the game. For example, back in episode 60 of AI in Games, we looked at the Drivatar AI in the Forza series. The Drivatars are being trained to learn from data you create as you play the game. But while the earliest entries in the series trained the Drivatars on your Xbox, since the Xbox One, the Drivatars are trained outside the game on an Azure server. In fact, if you pay attention before a race starts, you can see the trained models being downloaded onto your device. So for little learning machines to work, you need more than just the code to run a trained network, what we would typically call inferencing. You also need an entire learning environment running underneath the game as you play it. The actual training system relies on the Unity ML Agents Toolkit, a library first released in 2017 that provides users with the ability to train AI agents using reinforcement learning in the Unity engine. The game relies on the PPO or Proximal Policy Optimization algorithm to train the Animos, which, once you configure the environment, it runs the actual training using an external Python system, given it's relying on many contemporary machine learning libraries and tools available in that language. But while Unity's ML Agents works pretty well, it's not built for use in real time in a video game. Rather, it's designed for use during development. As such, the dev team had to reproduce much of the underlying guts of the ML Agents toolkit to work within the game while you run it as a playable executable. In fact, eagle-eyed players will have noticed that the first time you start the game, it spends a couple of minutes installing PyTorch and setting up the virtual environment it needs to train the Animos as part of core gameplay.
So there was at some point there was like a lot of decisions to make. It's like, okay, do we make a game, or do we like make this like RL algorithm inside the game? And it always came out to these decisions of like use something that already exists or try to make it ourselves, and all at the same time trying to we need to prove that the concept works. So it was a continuous effort of trying to prove the concept works. So the first thing we did was use ML agents like straight up, using the standard ML agents like pipeline, and that worked. It took long. It took like 30-40 minutes to train, and like we did that. But it required using the Unity editor to train. So the game only really ran inside the ML agents like workflow, which is the standard ML agents workflow. But it proved that it was possible. And then we had the choice. It's like, okay, well, do we rewrite it from scratch? And it's like, no, we're on a deadline here. Let's move some of this around, and then okay, well now we don't have to do it in the editor. We can do it in this like standalone version. Oh, but now the game design is kind of questionable. We need to iterate on the game design, and we have all this like logic that we have to write. Let's just write it using like C#. And now we wrote this like grid system. So it's like, oh, there's trees, and you can plant them, and there's fire, and the fire spreads on the trees, and like there's a lot of like gameplay mechanics. And a lot of it was trying to do expressivity, trying to like do complex like game mechanics, so that the world didn't just feel like a toy grid world. So trying to get that done in time kind of led us to have all this bunch of logic in C#. But then we had this other concern, which is like, oh, now it's taking too long to train. And noticing that was kind of like the bottleneck. That's when we kind of did this system to transition the logic, still doing it in C#, but not inside Unity, to kind of cut on all of that overhead. And what's actually really, if you don't mind me telling a bit of a personal story here, but this developer we're working with, his name is Anush Patel, and again, he was a very like iterative kind of, he liked making games, and he like really believed in this project. He joined it, and then towards like the middle of the project, his work was like, take all this logic and like refactor it. And like do this refactor. We need to strip out all the Unity dependencies. We need to write tests for it. We need to make it into this DLL. And he said that this was excruciating and boring because it wasn't like, it didn't feel like actual game design. It didn't feel iterative or interactive, and it was kind of annoying for him. But he did it, and he managed to get it all done by like the time that we had to get this like Next Fest demo out. And then he went on vacation. And then while he was on vacation, we managed to finish the integration on the Python side. And thanks to all the work he did, we were able to combine those two things. And that's where we got our like amazing 10x speed up because of that. The unfortunate thing is, while he was on vacation, he passed away. So he never got to see the results of like months of like grueling work to get these two things like connected.
With all of this working, it still leaves one big issue, and that's the hyperparameters, the specific training settings used by the algorithm itself. While players configure the Animos learning problem in the cloud, each animal will still run the same PPO algorithm under the hood, using the same hyperparameters. Little Learning Machine's biggest selling point is the idea that you can complete this in real time, and so a lot of trial and error during development was ensuring the hyperparameters allowed for agents to learn quickly, but without risk of them never learning anything useful. or equally having the issue of overfitting, whereby they can only solve the problem you give them in the cloud and their knowledge doesn't adapt to the actual in-game puzzles.
And like, especially when assigning rewards, I think like a lot of the game is a process of assigning rewards, and there's ways to kind of like literally tell it what to do at like give it 5 rewards at a time. We max it at 5 rewards because then it just gets messy after that. That was another decision we had to make. And last thing about the hyperparameters was like, so each of the Animo have like fairly consistent hyperparameters, like maybe slightly different because some of them have like vastly different observations. But there was a moment like almost like 2 months before we shipped the game that we designed a hyperparameter panel, and we're like, oh, we could just ship with this, and but then we're like, this is too much. This is
is there a hidden console command that will pop this up that I can be like, ooh?
So you can actually, if you go into the files of the game, there's a standard YAML file which is derived from Unity's ML agents library, which is, you can edit the hyperparameters there. You're on your own. If you do that,
hey, I know how to do that. I've run professional training on how to use that stuff. Okay. So
there you go, power user.
Maybe not for the purposes of the video, right? Let's play it as intended, right?
There's not only creative space for the player in that sense, but creative space for the agents themselves, the machines. Sometimes you'll train one of the machines for a particular task, and then you're seeing them apply that skill set to another problem, and there's creative space for the little creatures as well, and that's part of the fun of the game is watching them figure things out, and the surprise and delight that comes from problem solving from something that you never really planned for.
And so with the technical architecture in place, the next big challenge was in building puzzles for the game. But this challenge emerges in multiple forms, both in terms of trying to come up with puzzles that will encourage players to try different training configurations for the Animos, but also in ensuring that players are actually understanding what's happening under the hood and can adapt to suit.
I think the dogs are actually a really nice touch, because you're like, oh cool, I'll go and pet a dog. Oh no, the dog's moving now. And of course, critically, you made a key mechanic of the game petting a dog, because the internet demands that if there's a dog in your game, you got to pet it, right? So, what was that process like of just putting all the puzzles together? It seems like, just even from the conversation, it sounds like all of you chipped in somewhere. Everyone had something to contribute to this whole process.
The iteration is the key. We spent a lot of time working on this project, and at the beginning, like Dante mentioned, we didn't necessarily know how smart they could be, so we couldn't potentially design, we had ideas of how smart they could be, so we could potentially have ideas of the difficulties of the quests, the kind of tools they could use. Once we proved that, they can, pick up an item and use that item on something else and navigate a space, and then even proving that, they can choose between multiple items in the right context and get to that point, then we could start thinking about what kind of items do we want to include in this space. And then the hardest part, which we're kind of iterating up into the end, was the kind of order in which we try to kind of introduce players to basic ML concepts, basically to get them. I think the goal was if we can get the players to kind of get up to my level of understanding, because I am an amateur and I'm not an engineer, and if we kind of get people to kind of understand these things to maybe the point where I could, then that we would be kind of successful in that way, and then they could train well, because I could train well. I don't fully understand it, but I can train well. Seeing the Animo do different kinds of tasks are also rewarding in different ways. Seeing an animal water a flower is one thing. Seeing one destroy something, seeing it manipulate its environment is very satisfying. We have one item, the block maker, which it can use to make bridges, which inherently is kind of one of the most satisfying things I would feel to train, because you literally see it making decisions and building, kind of manipulating its environment, which seems almost for some reason a bit more intelligent than other behaviors, even though it's kind of doing the exact same kind of thing. And so it was a development or an iterative process of like, when do we introduce these items? How complex are these items? Later in the game, there's like all the final quests are multi-animal quests. How do you get them to collaborate? It's very hard. So we iterated all the way up till the end to kind of get that working well. And then if going all the way back into the beginning, like, we were always around a whiteboard brainstorming, like, what kind of items could we use? What could these items be used for? And so we're all part of that. And one final thing is, like, we have a really talented artist, Reese, and he designed all these really cool, like, styles for levels and stuff like that. And so it was kind of also baked into, like, when do we want to reveal this environment, and what kind of, like, item do we want to use that's accurate to this environment, or the environment could kind of, like, help you kind of understand what is supposed to be done here.
And also, like, Fiona was like, can we have pumpkins for Halloween? Can we have, like, snowmen for Christmas? And it's just like, okay.
I love a good theme pack, so I'll never shy away from a good holiday themed.
You got to plan that in there, right? You got to make sure you got it in there in advance.
At Transitional Forms, especially, like, going into this game and is like this kind of empathy to the machines to some extent. Like, that was a really huge goal for this, is to somehow empathize. But in order to empathize, I think you need to learn about something, and the more insight that you have into specifically all these kind of, like, the process that they're going through, or the different actions they're taking, and the black box to some extent, the more understanding you can have, and potentially the more, like, empathy you can have to these creatures that you're going to literally throw in the garbage as soon as they don't do what you tell them. When it comes to, like, all those different things, a big kind of thing that we included in the end was just, while it is just a single instance, when you're training, you're watching a single instance and there's actually multi things, was just actually including, like, when they receive a reward in the cloud, there was, like, a long period of production where, like, you didn't see the reward pop out of their head when they took the proper action. And just, like, the smallest, that smallest little thing, when we, like, finally got it in, was just like, oh, now, like, people can see that, oh, this reward is tied to this action they took. And, like, that in itself seems like the simplest thing to us to some extent, but without it, like, people were completely lost.
It's no secret that training an AI agent there's a large barrier to entry if you are not familiar with what is going on and what all this crazy technology is. I don't come from a technical AI training background. So when I joined the company and found out about more information about little learning machines and, like, how it was working and everything, I was like, oh my goodness, like, this is crazy. And, like, crazy that I can explain this to people now, like, after playing this game and still not having, like, formal educational training. And I think there's a real beauty in the fact that you can turn on this game, play it, kind of just play it for the cute purposes. Play it because you want these machines to succeed and you want them to grow and you want to see what happens and you want to explore the world. But at the same time, afterwards, when you're explaining to someone, oh, this is how I got my machine to learn how to cut down a tree, you're quite literally explaining the process of training those agents. One of the things that we did, actually, because of course there's such an educational component of this game, was we made a learning companion, which is basically a lesson PDF that can be provided to educators to help integrate, like, classroom learning with little learning machines. Because, again, barrier to entry is high and it's scary if you're just looking at this wall of code and just everything else. So by having this kind of cute, cozy, friendly, approachable system, it just helps get the familiarity out there. Like, these systems, these processes, they're not going anywhere. They kind of are the future. So getting more people exposed to it is so important, and in a way that shows you empathy and makes you, like, emotionally invest in the characters, I think is just super cool.
Little learning machines is certainly something unique in the gaming space. It's not often you see a game that tries not just to apply AI in a way that, certainly from my perspective, is fun to tinker and play with, but earnestly seeks to teach its players about how the underlying technology works. I mean, yeesh, if everyone starts doing this, I'm going to be out of a job. Or whatever you call this content creation purgatory I've trapped myself in. Anyway, This video is of course expertly timed, as Little Learning Machines is receiving a big content update on September 5th on Steam, with a stack of new islands to visit and quests to complete. 18 of them, in fact. Critically, this update doesn't just revisit existing mechanics with new twists, but it also provides new routes of progression, by helping make the learning curve for training your Animos a little smoother. Plus, there's 6 new costumes as well. Always nice to have some fresh cosmetics. A huge expansion to the game at no extra cost. I'll leave the Steam link in the video description and pinned comment for you to check out. In the meantime, thanks for watching this episode of AI in Games, all about Little Learning Machines, and a special thanks to Dante, Fiona, Nick and Pietro from Transitional Forms for sitting down to chat with me about their experiences in building the game. If you're keen to find out more about the underlying tech, I've also left links to presentations by the team on its inner workings. Plus, we have a dedicated episode of the Branching Factor podcast, where Dante, Fiona and Nick chat with me some more about their experiences in a slightly less formal setting. And with that, I'm off to train me some more Animos. Delightful wee critters. Stay safe, take care, and I'll be back.